Hey folks, hope you are all having a great day today. One of my favorite sayings is the best lessons learned are the lessons earned. And what that means is by getting out there and actually trying something and possibly failing, that's when you will learn the most. And don't get me wrong here, you can learn a lot from the mistakes of others, but by actually getting out there and doing it yourself, that's when you're going to learn the most. It doesn't always have to be failure. You can learn a lot by simply trying something new. And that's the theme of this video and this project. Lots of lessons learned by trying something new, but also lots of lessons learned by failure. And not major failure, as you'll see, but there's a little bit of failure here. With this project, I'll go through the thought process at each stage and talk about the lessons learned. The goal for this project was to create some nice end grain inlay cutting boards, and I'm starting by cross-cutting the rough sawn maple and Bubinga at my miter saw station. Now the inlay design that I'm going with is the Mississippi State University logo, and these two species are a good choice for the maroon and white university colors. After cross-cutting, each board is jointed on one wide face and one narrow face, and then planed just enough to remove the rough sawn surface. I wasn't going for a specific number, just trying to get maximum yield by cleaning up the board. To help randomize the end grain pattern, I made a few rip cuts at the table saw to just give me more pieces to glue right back together. Now I know someone's going to ask about these green gloves. They are tight-fitting nitrile, I think I'm pronouncing that right, nitrile gloves. And I use them for better traction when my hands are dry and cracky. When you have dry and cracky hands, you don't really have much traction. So these are tight enough that I still get the good tactile feedback of working with bare hands. You want to be able to feel the wood as you're pushing it through machinery, but also they don't get in the way. So they have a bunch of small little bumps that help with grip. Before gluing the boards back together, I twisted them around to get an alternating grain direction on the end grain faces, kind of like a smiley face, then a frown face, then a smiley face, then a frown face. And this is for two reasons. Number one, just to give some visual randomization, because the end grain face is the face that will ultimately be seen. And number two, it's for long-term stability as the wood moves. If you have all of the grain in the same, I guess if it's all nothing but smiley faces, then odds are it's going to bow and cup all in the same direction. And you don't want that. You want any movement to cancel each other out with the smiley face, then frown face, and smiley face, and frown face. And the glue up brings me to lesson learned number one. Don't use a lot of glue for the first glue up. I don't know why, but I always use way too much glue on just the very first glue up. I know that I do this, but I continue to do it for some reason. It's just so wasteful and it's so messy. It's a lot easier and a lot cleaner to add glue in places where it's needed than try and fumble around with all of the extra glue. Naturally, I used a lot less glue on the maple board. After letting the panels dry overnight, I started the next day by planing them flat. Now the Bubinga board, it was just shy of 16 inches wide, which is the maximum capacity of my planer, so just a couple shallow passes through the planer is all it took. Very quick, very easy. The maple board, on the other hand, it was just a little bit wider than the capacity of my planer. I think it was around 17 inches wide, so I used the drum sander to clean up the glue squeeze out, as well as I think I had one or two of these boards shift, which is it's no fun. So you gotta level out the board again, and that's where lesson learned number two is: use the correct tool for the job. A drum sander should be used with the intention of sanding the surface and not with the intention of thicknessing a board, generally speaking. So, the drum sander worked in this situation, but it was incredibly slow, which caused me to get too aggressive with the material removal because I am an impatient person and therefore ruin the sandpaper prematurely. So in my case, the correct tool for the job would have been my CNC machine. It has a 24-inch wide cutting width, so it would have been more efficient use of time as well as resources to use a wide spoil board surfacing bit to flatten the panel. Next, each panel is cross-cut at the table saw with a cross-cut sled to establish one square end, and with that freshly squared end against the fence, all of these smaller strips can be cut. Notice two things here. Number one, I'm flipping the board every time I run it through, and that's to cancel out any type of accidental angle or accidental taper that I'm putting on all of the cut pieces. And number 2, notice that I'm not leaning over the blade to remove the cut piece. I know that sometimes it's unavoidable, but whenever possible, don't lean over the saw blade for obvious reasons. It only takes just a small amount of effort to stand to the side before reaching over the material. Now, I saved a little bit of each of the panels to cut into smaller strips for the inlay material, and these pieces were cut about 1/2 inch wide, if I recall correctly. With everything cut, I laid out all the pieces to see exactly how much material I had, and my original plan was to make just 2 end grain boards, one large maple board and one large Bubinga board, but that changed here as I thought the Bubinga board was just a little bit too long. It wasn't proportionate. You know, the proportions were wrong. So I broke it up into 2 boards, and I also took 2 strips out of the maple board with the intention of cutting them into 4 smaller strips to border each one of the Bubinga boards, but you'll see later on that I ended up not adding these. Then it's more repetition of gluing panels together, but this time the pieces are rotated so that the end grain is facing up. And this time I also got tired of using a brush, so I switched over to a small roller, which is what I should have been using from the very beginning when gluing together this many panels. But the thinner inlay material is also glued up the exact same way. After letting these glue ups sit overnight, I started the next day by flattening the large maple panel off camera at the drum sander, which again I should not have been doing. And just like the Bubinga board, the maple board just seemed a little too large once it was all glued together. So at this point, I cut it into 2 smaller boards, and finally on day 4, the inlay work can be started. So the 2 bits that I'll use for this entire process are a 1/4 inch end mill to remove the bulk of the material, and a 60-degree V-bit to establish the shape of the inlay. Making a V-carved inlay allows you to have sharp interior corners, unlike a straight wall inlay cut entirely with an end mill, where you are limited on the interior corners by the radius of the bit used. With the Z-axis height set, the bits can go to work cutting the inlay, and first the bulk of the material is removed with the end mill whenever possible, and then the actual shape of the inlay is established with the V-bit. And you'll notice a lot of fuzzy pieces here where the V-bit is cutting around the pockets. I'll address that in just a little bit. While the CNC was at work, I was using the drum sander to clean up the Bubinga boards, letting the CNC do its thing while you do something else. It's like having a cheap hourly employee who's always ready to go and doesn't show up late or drunk for work. Here you can barely see the MSU design, but this is the second maple board after it was cut. And with the maple boards cut, I turned my attention to the Bubinga inlay panel, first with the end mill, and then second with the V-bit. Now the amount of fuzzy ends here really made me start to wonder what in the world was going on, because I didn't see that in all of my testing pieces, but it only took a minute to break off the fuzzies with a flat screwdriver. Nothing crazy. And I'm really good at screwing up the simple things, so I used a highly visible marker to let me know exactly where I need to cut while at the bandsaw. And while at the bandsaw, that leads me to lesson learned number 3, and that is to just let the CNC do more of the work when cutting the inlays. Rather than making a simple rectangle around the inlay vector and letting the CNC cut all the waste to that rectangle, I thought it would save time on the CNC machine by offsetting the vector shape and then cutting out what I need at the bandsaw. And well, it probably would have saved time if I had a blade in the bandsaw that allowed for tight radius cutting. I simply did not. I have kept this Resaw King blade in the bandsaw since day one, and it's not set up for tight curves at all. So lots of extra bandsaw work that would have been eliminated by simply using a rectangle on the computer rather than offsetting the vector I wanted to cut. So lesson learned number 3. Now the first inlay material can be glued in, and for some of the inlay, it's a true V-carve, and that means that the V inlay will bottom out in a V pocket, a nice tight fit. Every place that the 1/4 inch end mill touched, that's where there's a flat bottom and a little bit of space for glue, extra space for glue. This ended up being a problem, and another lesson learned that, once again, I'll get into in just a second. Lots of clamps and calls to get even clamping pressure, and I didn't have enough long reach clamps to glue all the boards at once, so I only glued the inlays in the maple boards first and let them sit overnight. On day 5 of the project, I started by cutting off the bulk of the inlay waste at the bandsaw, and while this worked quite well, it was a little more nerve-wracking than I would have liked due to the amount of blade being exposed while passing something tall and proportionately thin through the saw. But as always, if you take your time and are mindful to avoid the possible dangers, then it should work out all right. Next up is to start the cutting process on the maple inlay panel, and this shows how much the panel bowed after cutting. I was a little shocked about this. As soon as I removed the clamps on the front side, the panel just bowed up real bad. I was worried that this amount of movement would cause issues when fitting the pieces, but it ended up not being an issue at all. It was just interesting to see. During idle time of the CNC machine just running, I started the cleanup process on the maple boards by running them through the drum sander, and when the time came to run the Bubinga boards on the CNC, I did a little bit of sequence testing with the 2 cutting bits. The first test was to run the V-bit profile or the V-bit toolpath first, and then the end mill second. And the bottom of the cut here it's clean and it's acceptable for this particular inlay, but it's not perfect. There's just a little bit of fuzzies, and I think this is because it's an end grain cut. Now, the second result, the second example here is the result of cutting the end mill first and the V-bit second, and as you can see, the results are nowhere near as clean where the 2 bits intersect. Now, it's the exact same toolpaths, the exact same bits. I noticed that this fuzzy intersection only happens when cutting the end grain and not a long grain. So my thinking is that the grain in this orientation is like a bunch of straws standing on end. It's easy to cut through the straws the higher you go or the grain the higher you go, because the bit is moving faster because it is away from the center of the bit. Because the V-bit comes to a point, the rotation speed and surface area covered at that point is much less per the same revolution, and therefore not as effective at cutting. So if you stand a stack of straws together and swing with a sharp blade, there shouldn't be any issue cutting them. It should just cut right through them. But if you try to cut the same stack of straws right at the base, where they're fixed permanently to something else, and you go much slower, then you're more likely to bend and push the straws over than you are to cut them clean, if that makes sense. That's what I think is happening here. The end grain fibers are just being bent over because the empty space where the end mill cut first isn't offering any resistance. But if the V-bit cuts first, there's no room for the pieces to bend over. They just cut as best they can, and the bottom of the cut, it doesn't always cut perfectly because there's just not much speed there. And after all the major CNC work is done, the final inlays can be glued in place, and once again I let these sit overnight just to do all the final cleanup on all of the boards at the same time the next day. Day 6 was a little bit disappointing, I have to say. It was the day that I realized my inlay technique mistake. After getting all of the boards flush with the drum sander, I noticed a very hollow sound coming from the large inlay surfaces. And I knew immediately what the problem was. When tapping on the area where the flat bottom was cut in the inlay process, that's where the hollow sound was evident. This means that there's too much of a hollow area or too much of a gap for glue under the inlay, and therefore the boards can no longer be used as cutting boards, which kind of sucked. I wanted to give these away as cutting board gifts, but instead these inlays instantly became over-engineered wall art is what I'll call them. At this point, I was just frustrated with myself. I was following a PDF inlay guide that I found online and previously tested with good results. Here's a picture of my test board that I cut a week or so prior to cutting these. So I followed the exact same guide with the exact same toolpath settings. So why in the world did I get such a drastic difference on this project? And then it all made sense. The specification for a flat depth on the inlay, that's where the problem lies. On my first attempt at this piece, I forgot to flip the inlay vector, so it didn't even work at all. Now on my second attempt, I had to reduce the overall size of the vector due to the scrap wood that I was trying it on being smaller, and in doing so, I completely eliminated the end mill altogether. So the second attempt was entirely a true V-carve. Let's talk about how a V-carve works really quick in comparison to an end mill cut. So when cutting out a design or an inlay pocket with an end mill, the walls of the cut are vertical and the bottom of the cut is flat at a specified depth. Now when cutting out a true inlay pocket with a V-bit, there is no flat on the bottom of the pocket, and the depth the V-bit will plunge is determined by the width that the cut needs to be. Sometimes this can be a problem, as you will have to go deeper than the thickness of the material to get to the full width of the cut. In those situations, a flat depth can be specified, and the inlay pocket will be broken up into two tool paths. One pocket tool path with an end mill to more efficiently remove the bulk of the waste and establish a flat bottom, and one V-carve tool path to establish the exact shape of the inlay or design. Being able to just identify the problem wasn't really good enough though. I wanted to see the exact gap that I had and the exact inlay thickness that I had over the larger areas. So I went back to the computer, modeled a simple rectangle inlay with the exact toolpath settings I used, cut out the contrasting scrap blocks for the inlay, glued them together, and waited until the next day and cut it in half. And this is the result. I also included a pencil in the photo for scale, but what you're looking at is a 0.1 inch gap below the inlay for excess glue, a 0.1 inch layer of actual inlay material when it's all said and done, and a 0.1 inch amount of waste material on top for a clamping surface. So for decorative inlays where you're just looking at a design, the guide I followed is a foolproof instruction to get great results. For an inlay that demands actual structural strength, such as a cutting board like I was trying to make, the gap at the bottom for excess glue is just too large, and this was confirmed by talking with a few people on Instagram who make inlay end grain cutting boards successfully and actually do not allow for any extra glue or any extra pocket area below the inlay. That information, combined with the fact that every shallow V-carve cut on these inlays is a 100% fit and there are no problems with the alignment due to not having any glue, not having a place for the glue to go, tells me that lesson learned number 4 is to not add any additional space for glue when making a V-carve inlay on the CNC machine. By day 7 of this project, my productivity and interest level tanked. I just didn't really care about this anymore. I was working on this on and off with other things going on in the shop. I just wasn't interested in the project anymore. So I decided to not add the contrasting trim to the border of the Bubinga boards and instead just get done with the project. So from this point on, the goal is to just finish the pieces as wall art. First up is to square all of the boards at the table saw with my crosscut sled, followed by sanding up to 180 grit. The drum sander is great for leveling surfaces and doing the rough sanding and saving a lot of time, but some other type of sanding is still necessary to remove the scratch lines that the drum sander puts into the workpiece. And for that, I want to mention a couple of convenient grippy items that Rockler has for preventing material from moving while on the workbench. So not only are these blue silicone mats great for keeping glue off your work surface, they are also great for holding the workpiece while sanding, and an even better item for holding the workpiece via gravity and friction are these bench cookies. My experience is that I've been using these way more than I thought I would, and they're just incredibly convenient for a lot of different work holding tasks. Now, because these are not cutting boards anymore, my planned finish of mineral oil and beeswax was replaced with shellac. Now, I knew these end grain boards were going to be really thirsty, so first up is a few flood coats on the visible surfaces, which brings me to lesson learned number 5. Always remember that wood movement due to moisture is faster and more noticeable on thinner wood than with thicker wood. This is something that I already knew, but was unpleasantly reminded of after a couple hours of letting the flood coats of shellac cure. You can see here how the thinner center section of the inlay swelled up, making the glue seam areas stick out like a sore thumb. So this just means it had to be sanded back to an acceptable amount until I just eventually stopped in fear of cutting through the inlay. It's not perfect if you really look close, but oh well, it is what it is. These are going to hang from the wall, and the easiest way to accomplish this is with a keyhole slot cut in the back. And because these need to be clamped to the machine surface with the good side facing down, I figured it'd be a good idea to get this step done before completing the finishing stages. It probably should have been cut before I applied any finish at all, but I forgot about it. So just a quick back and forth with the keyhole bit on the CNC machine is it's all that's necessary. Makes quick work of this little process. And finally, the rest of the shellac can be sanded with 320 grit sandpaper to level the flood coats. So here, if the shellac is balling up on the sandpaper, then that means the shellac needs more time to cure. If the shellac is just producing a fine dust or a powder and the sandpaper remains clear, then you're good to go. After removing all of the dust off the surface, a handful of thinner coats of shellac can be applied with a balled up rag. These thin coats, they dry incredibly fast, so by the time I rotated through all of the boards, the first one was already perfectly dry and ready for another coat. And I think I just went through all of these and added about 5 more coats this way. After letting the boards sit overnight once again, I began day 8 with the final finishing steps. Multiple layers of shellac. They always produce a finish that's a bit too shiny for my liking. It's kind of a gloss finish. So I evenly scuffed up the surface of each board with fine steel wool to get rid of the high gloss shine, and then applied a layer of paste wax, and then quickly wiped off as much as I could for an even semi-gloss finish. If you apply the paste wax and let it harden and then buff it out, you're just going to get a really shiny surface once again. So put it on, wipe it off. And here's the final result after lots of fun in the shop, lots of frustration in the shop, and lots of lessons learned. Ultimately, the lessons learned are the most important and rewarding takeaways from this project. Every time I talk about mistakes, there's a lot of people who say that I'm just being too hard on myself. And while I understand their perspective to a certain degree, I have to disagree. I don't beat myself up mentally. It's all about acknowledging the areas for improvement and using that information to get better, to do a better job next time. So I'll end this with the 2 perspectives that I personally have on this build. One side of me is kind of, relating to the guy who batted his personal best, had a couple RBIs and a home run. And that's the part of me that thinks that the end result is great. These are nice wall decorations. The other side of me, that's the same exact guy who missed the ground ball and let the winning run come through in the bottom of the 9th and lost the game for his team. That's the part of me that was wanting to give these away as some really nice cutting boards, which isn't going to happen. I don't think either one of those perspectives is wrong. Just lessons learned, and now I am more informed for the next time. Thank you to Rockler Woodworking and Hardware for supporting this video. For more information on this build, check out the links in the video description if you are watching this on YouTube. You guys take care, have a great day, and I'll talk to you in the next video.